Good morning, class. Today we're going to be working with data binding. And to start us off, we have a program that's very similar to the one we did with the shopping list last time. So we have a to-do list. It has a text box and a button that we can add items to this list. And we've done a little bit of styling to make that look nice. The big difference here is instead of just putting that task string directly into the list of items, we are actually creating a to-do item instance with that text. So the to-do item is a custom class we also have written here that takes or has a task property, which is the string describing the task, and a Boolean property, which tells us whether or not that task has been completed. When we construct it, we just go ahead and throw the task in there, and we overrode the toString method so that it will tell us when we invoke toString the task and the current status. We go ahead and run that. We see our to-do list, and we can add stuff to it like wash the car. You can see that toString is being invoked and being used to populate this list. So even though we're putting an object into the list, that object is in turn being converted to a string to be displayed. So the first thing we're going to do is we're going to change how this control is rendering that object. So if we come down to our list view, we've basically just got a default list view here. We're going to make a couple quick changes to that, and one of the big ones is we are going to change its item template. The item template is what determines what the item is going to look like when it's displayed in the list. And right now, if we actually were to tear it open, it would look something like this. We'd have a data template, and we'd have a text block, and that text block's text would be bound to the object in the list. And because that object is a to-do item, this binding would bind to that item. That item would have its toString invoked, and then we'd replace that. Just to show you that this is exactly what that actually looks like under the hood. At the moment, we'll do again wash the car, and you should see wash the car incomplete showing up exactly like it did before. So we can change this data template to be whatever we might like it to be. So that's actually exactly what we're going to do. We're going to create a checkbox, and we're going to bind the isChecked property to our object, and then we're going to modify, instead of looking at the data to-do item itself, we're going to drill down to a path within that object, and we're basically just going to look at the complete property. So this will be checked if that is complete, and then we'll go ahead and move this text block binding in here, and instead of invoking toString, what we really want to show now is just the task. So we'll go ahead and change this binding to reflect path equals task. So this will use the Boolean property complete. This will use the string property task. And if we run this again, and now say wash the car, and add that task, and we can see wash the car appears. And if I were to add a breakpoint in our to-do item on, say, the task here, run this again, and wash the car. Notice that we hit this breakpoint because it's retrieving that task string from our class to actually populate this. So that's the basic idea behind data binding. Now what we have done here is technically a one-time data binding, because this is only coming and grabbing that value when we first render the control. So when we first render that list item. Now what we really want is, especially with our complete here, a two-way data binding that basically allows us to, whenever we click that checkbox, to have it automatically update this object. And to do that, we're going to have to make a few changes. One of the big ones is we want to go ahead and implement the iNotify property changed interface. And this requires us to add an event, which is the property changed event handler. property changed. And that is defined in system component model. And oh, I missed an L. Must have misspelled it somewhere. There we go. And this is an event fired when a property of this class changes. And actually, we say object. So when this task changes, we want that property to fire, and when complete changes, we want this property change to fire. And in order to do that, we're going to have to move away from the auto implementation of the properties. We're going to have to go back to using a private backing variable. And the reason we have to go back to a private backing variable is we need to actually put some logic in our setter to invoke that handler. We'll just return that lowercase task there. And for the setter, we got to do a little bit more. So we would normally just say task lowercase equals value. But now we also want to do the property changed, and we need to invoke that. And we're going to supply that this is the object that's doing the changing, so the individual one that's been initialized here, this specific to-do item, and then a property changed event args. And that takes one argument, which is a string, which needs to match this property name exactly. So it has to be spelled exactly the same, including capitalization. Now, it won't complain if you get that wrong, but it won't actually do what we expect it to do. And then there is one optimization you will sometimes see here. We might do a check if task does not equal value. Then we want to do these steps. Now this is optional, you don't have to do this, but the benefit of doing this test is if the task and value are already equal, then there's no need to set the property of task to equal the value because it already is. And the property technically isn't changing in that circumstance, so there's no reason to invoke this either. So by doing that, we eliminate a little bit of computation that could be happening when we set the task to what it already equals. We'll have to do the same thing with complete, private bool complete, and by default we want these to start false, and oops, that should be private as well. These are private backing fields, we don't want to expose them. And then we will return complete. And with our setter, we can do a similar if complete not equal value, complete equals value. So do the assignment property changed, question mark, period, invoke this new property changed. Then args, and in this case, complete is what we want to invoke. Okay. So, and again, this question mark syntax here, this just says that if property changed is null, which event handlers can be, don't do this part. So this will only fire off if property changed is actually has some attached event listeners. And that's really the only changes we need to make in here. We've added this property changed, we added this interface, and then we modified all of our changing properties so that this property changed event is fired. And this needs to be done anywhere in your code logic where those values change. So if that happens in a method, you need to call it in that method immediately after the change. If that happens in a property, you put it in that property setter. If it happens when a different property changes, you put it in that property setter. So wherever that change occurs, that's when you need to trigger it. Alright, so that hooks us up. Now if those properties change on us, that will make those values automatically update in this to-do list. So that gives us, actually we can show that in a little bit if we go to our to-do item and maybe put a check here on our setter, and we'll put one on our getter as well for complete. We'll run this binding exercise again. We'll add our task, wash the car, add that, and we expect it to hit the getter to get the false value that it is initially, and it does. And now if we check this box, notice we hit the setter, so now we are setting the value of complete to be true from its prior false value, and that's going to invoke this property changed. So if we continue, because this property changed fired, now the control is asking for what the new value is, so now we're returning true, and if we go back and look, the checkbox is checked. Now this is a little hard to see sometimes because it all happens in the back end. So we'll actually do some work to make it show up in the front end as well. Or actually, yeah. So we'll put it into the front end. And the way we're going to do that is we're going to change how we're actually storing the to-do items. So right now, we are putting these into just the control itself. And that works, but that's not the most desirable way of doing it, especially because if we look at our control, we have this 0 items remaining. We want this to change based on the number of items that are in our list. So we need to create a collection class that is going to be our data class for the entire list. So I'm going to go to our Solution Explorer, and I'm going to add a new class, and we're going to call this to-do list. So this is the list of all the items that we want to manipulate. And for this collection to serve as the data context of our control, we need to have it implement the iNotify property changed interface and the iCollection notify collection changed interface. So this one notifies for properties like we've already seen. This one notifies for the collection changing and as well as the individual items we're putting in here. We would have to hook up all of these. So we'd prefer maybe do something like a public or a private list of type to-do items, and then we'd have to hook up a bunch of event listeners to this list, so when this list changes we would do these notifications. Now there is an easier way of going about this. For example, we have defined for us in the C# libraries a class called object. Let's just pull a Google window over here. Observable collection. So the observable collection is a dynamic data collection that provides notifications when items are added, removed, or when the whole list is refreshed. So this is the default class we would normally be using to contain items in a control like this. In fact, the to-do list control, by default, the items that it has, so when we say items.add, this items is actually probably being implemented under the hood with an observable collection. And the observable collection, if we look at what it actually implements, it implements the iNotify collection changed and the iNotify property changed. So we can see that it has both of those, plus it implements the object model collection as the base class. So it gets a lot of the functionality we want. So instead of implementing these interfaces directly ourselves, we might think about extending the observable collection. And we want to use the to-do item as the contents of this collection. So now we don't even need to declare a collection. We are the collection. This is the collection that we're working with. And actually, we can start with just this. And if we go to, say, our window, main window, That's where we declare our list control, to-do list control here. Let's give that a name. And now in the code behind for the main window, we're going to set its data context. So, or sorry, equals a new to-do list. Okay. Whoop. And we have to throw our parentheses around that. So that will set that up and set us up with that to-do list, which means when we go back to the logic for the to-do list control, so in the code behind, we're going to change this logic. So we're going to check, first of all, if the data context of this class is that to-do list. And we'll go ahead and use the if expression, pattern matching expression, to assign that to the list. And we still want to create our new to-do task. And we'll set list.add, and we'll add this task to it. And then we will go ahead and do our clear step. So now, instead of modifying the collection directly, what we're doing is we're pulling it out of the data context and we're modifying it that way. So this is the collection that we set as the data context, and because we can treat it as a to-do list, then we're going to have potentially any additional control properties that come from that. Now, to finish this task, we actually have to bind the list itself. So this list view, since we're now pulling from the data context, we need to set up its items source to be a binding. And we're just going to use binding, which is going to bind us to the actual to-do list. And because that's an observable collection, it is an IEnumerable. It has all of those features of the list. So if we run this, it should hopefully just work. But need to make sure that the to-do list control we defined here, we have to preface the name with the X because this is part of the local namespace. We'll try this again. And there we go. If we say wash the car and add that as a task, notice it seems to work exactly like it was doing before. And so that works fine. Now what we want to do is come back to our to-do list, and we're going to add some properties. And specifically, we want a count of complete items. So public int complete count. And we're just going to write a getter for this. And what we want to know is how many of the items in this list are complete. So we'll go ahead and start with an integer, num complete, set that to 0, and then we want to iterate through all the items in the list. So we can do that with a for each, and we know each item is going to be a to-do item. And then here's where we get questionable. What are we looping over? What are we iterating over? Well, we're iterating over the observable collection, which is what this to-do list is. So we can actually just use this keyword there to say I want to iterate over my internal collection. And then we're going to check to see if this item is complete. If it is, then we will increase num complete by 1, so we'll increment that. And at the very bottom of this, we'll return our num complete. And we can do the same thing for an incomplete count. And of course, because this is a collection, it already has a just straight up count defined. So we'll do pretty much the same algorithm. We will start with a num incomplete integer set to 0 for each to-do item in this, and if item dot, or if not item dot complete to item in this. So if that item is not complete, Then we'll say num incomplete plus plus. And finally, return num incomplete. And of course, we'll want to add our comments. Number of incomplete tasks in this to-do list, and the number of complete tasks. And up here, we'll go ahead and say a class representing a to-do list. Okay, so if we run this again, well, actually, before we run it, we want to go ahead and bind in this case, the incomplete count to that to-do list control. So if we come into the XAML, we have up here, right here, this is the number and then items remaining to do. So we're going to change this 0 to be bound. And again, the data context here, so what we're binding to is that to-do list. And we can go ahead and set the path to be the incomplete count. And we can check that that is actually firing off. If we go to the to-do list, we can add to the getter a breakpoint. Go ahead and run this. And you notice that we immediately hit the I'm counting the incompletes. And initially that should be 0. If I add wash the car and add that, then our count should actually be 1. If I add another one, learn Spanish, that should be another task. This should now be 2. So even though the collection binding seems to be working, it is not working, and our to-do list is not actually letting us know that this property is changing or this property is changing. Actually, this one. We're not getting into here. And the reason we're not getting into here is we're not actually notifying of that change. So even though this implements the interfaces we need, it doesn't know that we've added this property. So we're going to have to manually trigger that this property is changing. And one of the places this changes is when the number of items in the collection change. So as we add items to the collection, as we move items from the collection, obviously these counts are going to change. So what we need is an observer, a listener, an event listener that will listen for that collection changed event. So we can go ahead and say void on collection or collection changed listener and object sender, and in this case it is a collection changed event args, or notify collection changed event args e. So when this changes, that means that probably both of these counts need to be recalculated. So we'll go ahead and do property changed period, question mark period, but notice it starts telling us that we can't access this property changed because it is defined in not this class, but in the base class of this class, and it's inaccessible in that base class. We're not actually allowed to touch it. And event listeners are kind of interesting, or handlers are a bit interesting in C# as well. Even though C# will let you define them as virtual and override them, that actually doesn't compile correctly. That behavior does not actually work. And if we go into the documentation, there is a warning there that you should not do that. See, I think it's in the event handlers. There, how to raise base class events and drive classes. So here, do not declare virtual events in a base class and override them in a derived class. The C# compiler does not handle these correctly and is unpredictable whether the subscriber to the derived event will actually be subscribing to the base class event. So the compiler doesn't deal with virtual events correctly as C# works right now. So what they usually will do instead, consider the fact events are a special type of delegate, can only be invoked within the class that declared them. Derived classes cannot directly invoke events which are declared in the base class. Although sometimes you may want an event that can only be raised by the base class, most of the time you should enable the derived class to invoke base class events. To do this, you create a protected invoking method in the base class that wraps the event. And they've done this in, for example, our observable collection. So if we look at the methods, there is this on collection changed and this on property changed. So these are methods for raising the property changed event with the provided arguments. So this uses the built-in property changed event handler in the base class and invokes it with the property changed event args that we supply. So that's what we're going to have to do here, is we would invoke on collection changed, or sorry, on property changed, which is defined in our base class in the observable collection. And then we're going to give it the property changed event args, and we'll supply, in this case, the names of the properties that are changing, which is complete count, and then also incomplete count. And then we need to hook this event listener up to the collection changed event, and we'll do that in the constructor. So we'll just add a parameter list constructor. In this constructor, we are going to hook up this collection changed listener to the collection changed event. And if I could type, it would go a little faster. Should be collection changed, just listener. It needs to match this one. So we've hooked up this event listener to the collection changed event, which is defined and the observable collection inherited by our to-do list. So now, whenever the collection changes, we're going to fire off the property changed event for the complete count and the incomplete count. So if we run this again and continue, add something, wash car, add that task, notice that now, because that event fired off, we are getting the new value of the incomplete count. And if I continue, we now have one incomplete item. Do taxes. And now we have 2. Complete the census. And now we have 3. Now the other thing we want to have happen is when we check these boxes, we expect this number to go down, saying 2, then 1, then 0, because these are now complete. But those are also not updating. And the reason they're not updating is the observable collection only listens for or responds to changes in the collection. It doesn't respond to changes of the items in the collection. So if we want to listen to those items changing, we have to create another event listener, void collection item changed listener. And this is going to be listening for property changed events. So we'll need a property changed event args and e. And there are 2 properties that can change. There's the task, and then there is the complete out of our to-do item. And if the task changes, that will not change our complete count or the incomplete count. Only if the complete changes will that change. So we'll want to do a quick check to see if e.property name equals complete. because only if that complete is changing are we wanting to fire off our own property changed event, which is going to be these two guys again. Just go ahead and copy paste them there. So if the complete property of one of our items in the list, one of the to-do items changes, then obviously the complete and incomplete count will change. And then we have to attach this event listener to the actual item in the list. And there are a couple different ways we can do that. We could, for example, replace the add and the remove method and use our own add and remove method. Unfortunately, with the observable collection, that is not the only way that you can add things to the list. For example, we can insert item, we can clear items. There's a number of other methods we'd also theoretically want to override to be as complete as possible. Now, we could instead take advantage of the fact that when this collection, when we add something to it, when we remove something to it, it fires off this collection changed event. So we will be able to see that the collection itself is changed. So let's go ahead and take a look at what those properties are. So if e dot action, for example, equals e dot and sorry, not e, but notify collection changed action, we have these four possibilities: add, remove, reset, and move. Add means that we've added some new items to the list, in which case those items will be in e.newItems. Remove means we've removed some items from the list. That means that those items will be in e.removedItems. And move really doesn't, it just moves it around in the collection, like reordering or sorting or something like that. So nothing is added or removed. So these are the two big ones that we want to deal with, is when this is an add or a remove. And rather than doing with a switch, an if, I'm going to go ahead and switch this to be a switch. And we'll just look at the e.action. And our first case would be that we're adding. So if we are adding something new to the list, what we're adding is going to be an e.newItems. So it's attached to this event as a list of items. So we could go ahead and iterate over that list, and we know that those new items have to be to-do items. Because this list is a collection of to-do items. And then for each one of those items, because they're a to-do item, we know that they have a property changed event handler, and we can attach the property, this listener that we just wrote. So we'll go ahead and attach that collection changed event listener. And that's all we need to do in the case of an add. Now, in the case of a remove, we are taking some of those things out. So we're going to do it for each again. e.oldItems. And we'll do item.propertyChanged. And this time we want to remove the event listener. The reason we want to go ahead and remove that is the nature of reference type. So when we take the item out of the list, we are technically done with it, and we don't need to hold on to it in memory anymore. But if this class, this to-do list, is still listing for changes on that, then that technically means that it's still in use, and the garbage collector won't collect that. So this creates a small memory leak that over time can consume an awful lot of memory. So whenever we add an event listener, before we dispose of the object that's attached to it, we want to go ahead and remove that as well. So that's an important step to do. And like I said, the move action, because it's just reordering things within the collection, that shouldn't affect the listeners that we've attached. That's perfectly fine. However, there is another case that we do need to worry about, and that is the reset. And the reset was added by Microsoft as kind of an optimization for when something really dramatic has changed this collection. For example, if we have a collection of several thousand items and we sort it, that's a big change because a lot of things are going to be changed in that process, and rather than trying to collect all the things that have changed and notify of all those changes, instead they just say, hey, start over from scratch, redo everything. So that's what the reset actually indicates. And with the observable collection, if you invoke its clear method, that will actually trigger this changed action. So it actually will reset it. So if that's the case, it actually means that probably we're going to end up with a memory leak. There's not a good way of dealing with this using the approach that we're doing. What we really want to do is capture, before this event happens, the state, take off all the event listeners, and then after that happens, re-add all of our event listeners. Unfortunately, that's not how this event actually operates. So in this case, we have kind of two options. One is throw new not implemented exception, which would basically say if you try to reset the collection, I'm just going to stop the program and try to avoid that memory leak. Or the other thing we can do is we can just iterate over every item that we already have. So every item that is in the list itself, and add the property changed event listener. Now this will make sure that we are catching all of the items in case some new items were thrown in, but it does in effect bring in the possibility of that memory leak. So it's kind of a trade-off of how do we best want to deal with this. Now in our case, we are not doing any things ourselves that should trigger that reset. So I would go ahead and probably do the not implemented exception and say notify collection changed action not supported. Dot reset not supported. So at least if this happens, we're giving some kind of feedback that tells us why this is not working. Okay, so now whenever we add something to the list, we're going to go ahead and trigger these two as well as add this event listener. And whenever we remove something from the list, we are going to trigger this guy. So we're going to remove all the items that changed the event listeners. And again, we'll go ahead and say the complete and incomplete counts have changed. So if we run this now, and add our task, wash the car, do the taxes, complete the census. And now when we check these, notice that the to-do number of items goes down by 1 or up by 1 as we turn these to complete or incomplete. So this is now totally all of these properties are data bound. They're all updating the way we want them to. It behaves exactly the way we expected it to. So now we have kind of our complete control, and we've used the data context to make this happen, and we've bound to the individual properties as well as to the list itself. So we've seen kind of a lot of the different things we can do with data binding in a pretty succinct little exercise. The last thing we'd want to do is just go through and finish documenting our new constructor and our change listeners so that we have everything up to snuff. And that's really all I wanted to go over in this exercise, so we'll go ahead and stop it there, and thank you for joining me. We'll talk to you later.